Scientific notation can seem strange when you first get to it, but it gets easier as you use it. And when dealing with either very large or very small numbers, which happens a lot in physics, it's extremely useful to use scientific notation. I'm Ben from Physics or Busts. Let's get into it. One of the first things is to change the number so that it's between 1 and 10, with 1 included. You can have 1.0, but once you get to 10, you'd have to move the decimal one more place. So for one example, I'm going to use the mass of the Earth. The mass of the Earth is 5.98 times 10 to the 24th kilograms. But if we were to write that out, we would have 598 and then have 22 zeros after that number in order to write it out all the way. And if we had to do that, if we didn't have scientific notation, we would be writing zeros for a really long time in anything that dealt with large numbers or even small numbers. So it's a way of condensing the material and making it more readable and more easily seen how big or small those numbers are. So if we look at this number, we have, from here, we'd have to move the decimal 24 digits, 22 because of the zeros, and then 2 more to get the number that we would read it being between 1 and 10. So that way we would write it as 5.98 times 10 to the 24th kilograms. One other notation that might come across is it can be written as 5.98 and then have a capital E 24. Right? That way keeps you from having to put superscripts in it, which makes it easier to type out that E to the 24 is the same thing as writing times 10 to the 24th. Right? But don't forget to put your units on there at the end also, because the units matter. If you're starting with numbers that are greater than 10, then the exponent is going to be positive. But if you're starting with numbers that are less than 1, then your number is going to be in the negative. So for instance, if we have this number, we'll go ahead and say 0.0000278 meters. Right? So when we look at that, we're going to write it as 2.78, because that would put the number between 1 and 10. And to do that, the decimal has to move 1, 2, 3, 4, 5, 6 spots. So that means we're going to do times 10 to the negative 6, because we had to move the decimal to the right 6 spots. So that'll be a negative 6 that you need to put there. Whereas with larger numbers, it'll be positive. When you're dealing with smaller numbers, you're actually going to have a negative in that exponent. And essentially what you're saying with that negative is that if we took 2.78 and divided by 10 times 10 times 10 times 10 times 10 times 10, right? Times 6 tens, that would give you this 0.0000278 meters. Okay. That's all that the scientific notation is doing, is it's shortening the way that you can talk about numbers so that it's a more condensed, easier to handle way of utilizing the numbers. Scientific notation is also really useful for showing how precise we know a number. For instance, if we just write the number 40,000, then that number could be anywhere between 35,000 and 44,900. Could be anywhere between there. But if we are going to say that we know it more accurately, that we know that it's 4.00 times 10 to the fourth, which is the same amount as 40,000. If we were to take the decimal, it would be 1, 2, 3, 4 spots, right? To make it to make this number between 1 and 10, we move the decimal 1, 2, 3, 4 spots. So we could write it as 4.00 times 10 to the fourth. So writing it this way in scientific notation can show that we know the number more accurately, that it's somewhere between 39,950 and 40,049. So there's only 100 unit difference that it could be between, versus when we just wrote it as 40,000, no decimals, there's a 10,000 unit difference that it could be in. So that makes a big difference for when you're saying how accurately you know the number that you're dealing with. Hope that helped you. Remember to like and subscribe, and I'll see you in the next video.